This problem A, we have an absolute value equation. So we isolate the absolute value expression, which is already done. We then split into equivalent equations. Each of these equivalent equations is going to begin with the exact expression that's inside the absolute value. On the right side, it's going to be set equal to what we have, 1, and on the left side, it's set equal to the opposite of what we have, -1. We then solve for each of these equations independently. So this is a quadratic equation. We're going to add 1 to both sides, giving us x squared plus x, no constant, is equal to 0. If we solve by factoring, we get x is equal to either 0 or -1. Do the same thing with the second example. We're going to move every term to the same side, giving us x squared plus x minus 2 equals 0. Looking for the binomial factors whose first terms are x's. The last terms are going to give us an overall product of -2 and a sum of +1, so +2 and -1, meaning our x values here are -2 or +1. So all we need to do is go back and check each of these. Let's plug in a 0. Absolute value of 0 squared plus 0 minus 1, is that equal to 1? Yes, so 0 works. Plug in a -1. -1 squared is 1, minus 1, minus 1, is that equal to 1? 1 minus 1 cancels, the absolute value of -1 is equal to -1, or is equal to 1, so that also works. Check the number -2. Get -2 squared, which is 4, minus 2 minus 1, is that equal to 1? 4 minus 2 is 2 minus 1 is 1. Absolute value of that is equal to 1, so that works. And then finally test the 1. 1 squared plus 1 minus 1, is that equal to 1? Again, the 1 and the minus 1 cancel, and we're left with absolute value of 1 does equal 1. So all 4 of those solutions will work. In the second example, again, B, we have an absolute value equation, so we isolate the absolute value expression, which is done. We then split. In each case, we begin with the exact expression that's inside the absolute values. Set it equal to what was given, 3x minus 3 on the right, and the opposite on the left. So we just change each of these signs. So a -3x and a +3. And then we're going to solve each of these equations independently. So we have a quadratic equation here with multiple variable terms. So we're going to move all the terms to one side. We get our x squared, add 3x to both sides, subtract the 3 from both sides, and then look to factor. The binomial factors with first terms xx. The second terms have a product of -3 and a sum of +2. So +3 and -1, meaning our possible x values are -3 and +1. On the right side, we do the same thing, move all the terms to one side. So we're going to subtract a 3x from both sides, and then add a 3 to both sides. When we look to factor this, our first terms are x's. Second terms are the two factors of +3, whose sum is -4, -3, and -1, giving us x is 3 and x is 1. So here are the possible solutions we need to check. If we plug in a -3 first, we get -3 squared is 9, minus and minus becomes +3. Is that equal to 3 times -3 or -9 minus 3? Absolute value can't equal the negative, so that is extraneous. Let's plug in and test 1. 1 squared is 1, minus 1, is that equal to 3 times 1 minus 3? Is 0 equal to 0? Yes, so 1 works. We'll plug in a 3 here. 3 squared is 9, minus 3, is that equal to 3 times 3 minus 3? We get 6 is equal to 6, so 3 works, and we already saw 1 is a solution, so we don't need to redo it. So 1 and 3 would be our answers.